Hello there, everyone. Thank you for visiting my channel today. And today I'm going to be doing a presentation on blockchain. Lots of people have been getting a lot of questions about what this blockchain thing is really about. And I decided to kind of do a little bit of research and come up with some information about blockchain, what blockchain is all about, just to give you, for those that don't have any knowledge or any understanding about what blockchain really means. I'm hoping that this presentation today, which is going to look over my research that I've done, will give you enough information to be able to give you a summary of what blockchain technology is really all about. So let's get started. So what is blockchain? So a blockchain is basically a distributed database that is shared between nodes on a computer network. Okay, this is in summary what blockchain is all about. So it's a digital database that stores information in electronic format. Okay, now the first definition is a little bit maybe a little bit nerdy, but then really what blockchain is all about is it's basically a digital database that stores information in electronic format. Now, blockchains are most well known for their role in cryptocurrency. Now, the this term blockchain became more apparent or more relevant when people started talking about cryptocurrency systems like Bitcoin and all the rest. Ethereum is another one. This is when people became the blockchain thing kind of came out there, and people started trying to find out a little bit more information about what blockchain was all about. Okay, so cryptocurrency is really, because most cryptocurrency are really built on using a blockchain. So blockchain, they keep it a decentralized and secure record of transactions. Blockchains are unique because they guarantee the security and fidelity of data records, and they generate trust without the need for trusted third parties. Okay, so what this is talking about is the way it's part of a decentralized body, and then it helps to guarantee security of the data and of the records, so that there's trust between the parties that are involved on this system. Okay, so a blockchain data structure is a key difference between a traditional database. So the structure of the blockchain is the real difference between a traditional database system and a blockchain. Now, blockchains collect information in blocks that are organized into groups. Okay, so this is the key difference here. Each block has a certain storage capacity and is linked to the previous field block. So everything is interlinked, okay, but it's also very secure. Now, this creates the chain of data called the blockchain. Okay, so this data structure, okay, where one block is linked to another block, creates a chain of data called the blockchain. Any new information following the newly added block is combined into a new block, which will be added to that chain once it's been filled. So what you're having here is a system of interconnected block that is secure. Okay, and this is what the blockchain is all about. A database typically structures its data in tables. Okay, this is just giving you a little bit more information on what how database is structured. However, blockchain structures its data in chunks or blocks that are then strung together. Okay, and this is where the security really comes in. The way it is structured, strung together, makes it more secure. Okay, when implemented in a decentralized manner, this data structure creates an irreversible timeline of data. So once a block has been filled, it becomes part of the timeline. All right, every block is assigned a timestamp when it is added to the chain. Okay, so every block is assigned a timestamp when it's added to the chain. So let's keep going. Key takeaways. So what are the key takeaways so far? So a blockchain is a shared database type that is different from other databases in how it stores information. Blockchain stores data in blocks, which are then linked via cryptography. Each time new data is received, it is added to the new block. So these are the key takeaways, like a little bit of a summary of what we've talked about so far. Once the block has been filled, the data is chained to the previous block. This allows the data to be arranged in a chronological manner. So a blockchain can store many types of information, but transactions are the most popular use. Okay, so things like cryptocurrency transactions and stuff like that, they are the most popular use of blockchain technology. Blockchain is used in Bitcoin's decentralized case so that no one person or group can control it. So this is the beauty about cryptocurrency and the nature of it. Nobody can control it. Okay, so everything is on a decentralized database such that no one controls it. Okay, instead all users retain control. So you retain control of your own investment in the system. So whatever you put into the system is what you control. You can't control what you don't put in. Blockchains that are decentralized and immutable can be reverted to at any time. This means transactions can be viewed and recorded forever for Bitcoin. Okay, so what is blockchain? I asked that question again. The blockchain's goal is to enable digital information to be recorded, distributed, and edited. So a blockchain is the foundation of immutable ledgers. Okay, this is another way you can describe what a blockchain is. These are records that can be altered, deleted, or destroyed. Blockchains are also known by the term distributed ledger technology. So this is another name. My research, I found that I didn't even know about this, but during this research, I was able to find out that another way you can describe blockchains is distributed ledger technology, DLT for short. The blockchain concept was first proposed in 1991 as a research project. Okay, its first widespread use in practice came in 2009 with Bitcoin. So since then, blockchains have seen a surge in popularity through the creation of cryptocurrencies, decentralized finance, applications, and non-fungible tokens, NFTs, and smart contracts. So these are the kind of the other fallouts or developments that have come in since all based on blockchain technology. So after Bitcoin, we started having other cryptocurrencies, decentralized finance, and non-fungible tokens, NFTs, and smart contracts and stuff like that. Right. A blockchain allows data from a database to be distributed across multiple network nodes in different locations. Now, this helps to create redundancies and protect the integrity of the data. If someone attempts to alter a record at a particular instance of the data, all other nodes will not be affected. Okay, so this is the enhanced security of nature of blockchain. One user could alter Bitcoin's transaction record, and all the other nodes would cross-reference to find the correct node. This system allows for a transparent and exact order of events. It is impossible for only one node to alter the information within the network. This makes it impossible to retrace the history and information such as transactions in cryptocurrency that has been stored. This record could include a list or transactions, but it's also possible for a blockchain not to have any other information, such as legal contracts, state identifications, or product inventories. A majority of the computing power on the decentralized network must agree to validate new records or entries to a block. Blockchains are protected by consensus mechanisms such as proof or stake and proof of work to prevent bad actors validating double spends or invalid transactions. These mechanisms enable agreement to be reached even if no one node is responsible. Transparency. Now, due to the decentralized nature, Bitcoin's blockchain transactions can be viewed transparently by having a personal node. You can also use blockchain explorers to view transactions that are happening live. Every node has its own copy, which is updated every time new nodes are added or confirmed. You can track Bitcoin wherever it goes if you want to. Exchanging platforms have been hacked, and those who stored Bitcoins on them lost their entire fortune. Although the hacker might be anonymous, the Bitcoins they took are easily traceable. It will be possible to trace the Bitcoins that were stolen during these hacks if they were ever moved or spent anywhere. So, is Bitcoin safe? Is Bitcoin safe? Is Bitcoin really safe? Blockchain technology provides decentralized security and trust in many ways. New blocks are stored chronologically and linearly. They are added to the end of the blockchain. It is very difficult to change the block's content after it has been added to the blockchain. This is only possible if the majority of the network agrees to do so. Each block has its own hash. If the information is altered in any way, the hash code will also change. Bitcoin versus blockchain. W. Scott Stoneter and Stuart Haber, two researchers, first proposed blockchain technology in 1991. They wanted to create a system that would prevent document timestamps from being altered. It wasn't nearly until 2 decades later that the first real-world application of blockchain technology was realized with the launch Bitcoin in January 2009. Blockchain is the basis of Bitcoin protocol. Satoshi Nakamoto, the creator of Bitcoin, described it as a new electronic currency system that is completely peer-to-peer and has no trusted third party. Blockchain versus banks. Blockchains are being touted as a disruptive force in the financial sector, especially when it comes to banking functions and payments. But banks and decentralized blockchains are vastly distinct. Let's see how banks differ from blockchain by comparing the bank system with Bitcoin implementation. What are the uses of blockchains? We now know that blocks on Bitcoin's blockchain store information about monetary transactions. There are currently more than 10,000 cryptocurrency systems that run on blockchain. Blockchain is a reliable method of storing transaction data. Walmart, AG Siemens, Unilever, and AIG are just a few of the companies that have implemented blockchain. IMB, for example, has its Food Trust blockchain that tracks the route food products take to reach their destinations. Currency. Blockchain is the foundation for cryptocurrency like Bitcoin. Federal Reserve controls the US dollar. The Federal Reserve is technically in control of currency and data. The client's personal information could be at risk if their bank is hacked. The currency value of the client's money could be at risk if their bank fails or if they live in unstable countries. In 2008, several banks that were insolvent were saved by the government. These were the fears that Bitcoin has created and developed. Blockchain allows Bitcoin and other cryptocurrencies to function without the intervention of a central authority by spreading their operations over a network. This reduces the risk and eliminates transaction fees. It can be used to give people in unstable countries or with poor financial infrastructure a stable currency that can accept more applications and allow them to do business with more institutions and individuals. Healthcare. Let's see how Bitcoin, how it relates to the healthcare industry. Blockchain can be used by healthcare providers to store patients' medical records securely. A medical record can be signed and generated on the blockchain. This gives patients the assurance that it cannot be altered. This private key could be used to encode and store personal health records on the blockchain. Now, what are smart contracts? A smart contract is a code built into the blockchain that facilitates, verifies, or negotiates a contract agreement. Smart contracts are subject to a set of conditions that users must agree to. These conditions must be met before the terms of the agreement can be implemented. Imagine a tenant who wants to rent an apartment with a smart contract. After the tenant has paid the security deposit, the landlord will give the tenant the key code for the apartment. The smart contract would receive the agreement from both the landlord and the tenant. It would then exchange the code for security deposit and hold on to it. A smart contract, I think I've been through this. A smart contract is a code built into that verifies, negotiates. I think I've been through this slide. Apologies. Now, voting. Well, this is another example of how blockchain is used. Blockchain could be used to facilitate modern voting systems, as mentioned before. Blockchain voting has the potential to reduce election fraud and increase voter turnout. This method could make it nearly impossible for votes to be tampered with. Blockchain protocols would ensure transparency and provide officials with almost instant results. This protocol will eliminate the need to recount or any concern about fraud threatening the election. Blockchain pros and cons. Now we're looking at just to kind of round up, before we round up, let's look at some of the pros and cons of blockchain. Blockchain's potential to be a decentralized record-keeping system is nearly limitless despite its complexity. Blockchain technology could have many other applications other than those we have already looked at. It can provide greater privacy heightened security, lower processing fees, and less errors. There are still, however, some drawbacks, and we're going to be going into some of those ones in a few seconds. Now, let's look at some of the pros of blockchain. Accuracy is improved by eliminating human involvement in verification. Another one is eliminating third-party verification, which can reduce cost. It is harder to alter the system with the decentralization that comes with blockchain. It is harder to alter the system for one individual to go in and alter the system. Because everything is decentralized, it is harder to alter the system, making it more secure. Transactions are private, secure, and efficient. The transparent technology. So technology is very transparent. So everybody can see what is going on. This service offers a banking alternative as well as a means to protect personal information of citizens from countries with underdeveloped or unstable governments. Now let's look at some of the cons. Mining Bitcoins requires significant technology cost. Obviously, to get everything set up, it's not always very cheap. Transactions per second are low. History of illicit activities such as the dark web. These are some of the other risks involved with it. Regulators vary by jurisdiction and are still uncertain. Then the last one, which I squeezed in here, limitations on data storage. I should have put that on a separate line itself. So we just looked very quickly at some of the pros and cons of using Bitcoin. So this was just a very quick presentation on blockchain. I'm going to come back later on to go a little bit more, do another presentation on some other things that have to do with Bitcoin, with blockchain. So thank you very much for staying patient with me for this past 20 minutes. Please don't forget to subscribe to my channel for more information like this on Bitcoin or all things to do with blockchain and cryptocurrencies and stuff like that. Thank you very much and have a great day.